This is a space diagonal for the Pythagorean theorem. In a rectangular prism, a space diagonal is a line that goes from a vertex of the prism. A vertex is like this right here, right down here at the bottom. That goes from the vertex of a prism through the center of the prism to the opposite vertex. So this is a 3D image, and the space diagonal is from the bottom vertex all the way to the top other opposite vertex. AKA, it's known as a stick in the box. And the whole point is you're supposed to try to figure out the length of a space diagonal in a rectangular prism. The Pythagorean theorem is useful when you need to find the length of that space diagonal in a rectangular prism. Side C is the space diagonal. So this side of the angle is the space diagonal that you're going to have to find. Alright, so they give you a rectangular prism with this side being 28, this side being 12, and the height being 16. So it's a 28 by 12 by 16 rectangular prism. And you've got to figure out the length of the space diagonal. So there's two ways you can do it. The first way is to use the Pythagorean theorem twice to figure out the space diagonal. So that's the way that we're going to try it out first. So right here where it says 1, start by considering the triangle ABC. So we've got this bottom triangle is laying flat on the bottom of the rectangular prism. It says to calculate the length of AC. So that's the hypotenuse of the square. I mean, not the square, the triangle. And this is converted to a picture right here. So we've got to find C, the hypotenuse. We've got A and we've got B. So the work for it is over here. You would do 28 squared plus 12 squared, and you'd end up taking the square root. That's just working out the Pythagorean theorem. And you get that length AC, the hypotenuse, is 30.5 centimeters long. And all we did was the Pythagorean theorem, A squared plus B squared equals C squared, to figure that out. So now we've got this length right here, and that is 30.5 centimeters approximately. Right? So now we need to consider the triangle ACG. So it is the triangle that's standing vertically. Is the one that we're going to have to imagine. And we have one leg that's 30.5, the one we just solved for, and they're given, and we are given the height of the triangle, which is 16. So we've got to use those two measurements in the Pythagorean theorem to solve for side AG. That's the space diagonal, and we've got to solve for that. So we would do 16 squared plus 30.5 squared equals C squared. You'd end up solving it all out, and you would get, once you solve for C, you would get that this distance is 34.4 centimeters long. The space diagonal is 34.4 centimeters long. So we did that by doing the Pythagorean theorem, and we did it 2 times to solve for the space diagonal. So that's one option. Perform the Pythagorean theorem twice. Or there is a formula that you can learn to find the space diagonal, and it all ends up being this formula right there. The height, or the space diagonal, is the square root of A squared plus the square root of B squared plus the square root of C squared. So they give you they'll give you the measurements of the rectangular prism. They'll give you the height, a width, and the length. So if you know this formula, the square root of a squared plus b squared plus c squared, you grab those three numbers, you plug them into the formula, and you will get the distance of the space diagonal. Now the trick is I don't give you this formula, so you have to memorize it. This is another way of writing the formula, but I don't really like that. All you need to know is that the space diagonal, D, equals the square root of a squared plus b squared plus c squared. If you plug the three numbers into this formula, you will get the length of the space diagonal. Alright, so back to that same exact problem that we already worked. If we use the formula, we would grab our three numbers, and AG is the diagonal, so D equals the square root of, we've got a squared plus b squared plus c squared. We grab the three numbers they gave us, the three measurements, 28, 12, and 16. We plug them into the formula, and we solve. So to solve that, we would say, we'd plug this in our calculator, the square root of 28 squared plus 12 squared plus 16 squared equals 34.4 centimeters. And it's the same exact answer that we got earlier when doing the Pythagorean theorem twice. So there's two ways: perform the Pythagorean theorem twice, or memorize the distance formula for a space diagonal. That's what the D stands for, space diagonal. The square root of a squared plus b squared plus c squared. And that gives you this space diagonal measurement. Alright, so this is just some practice to practice with the formula. All they did was know the formula for a space diagonal. They grabbed their three numbers and plugged it in to the formula and solved. So the space diagonal for this red box would be 13 meters. The second box, grab the three numbers, plugged it into the formula, a squared plus b squared plus c squared, take the square root of everything, and they got that this would be 38.7 meters for the space diagonal of this rectangular prism. Now you could do this using the Pythagorean theorem twice. It's whatever way you would like to do. This is just another practice problem. Grab three numbers, put it in, solve it. I like how this shows the work though, because we learned that we've got to do exponents first. So 6 squared is 36, 8 squared is 64, 10 squared is 100. Add all these numbers together and you just take the square root of 200, which is approximately 14.1, and you use your calculator to solve for that. So really, if you can memorize the space diagonal distance formula, this is the easier way to go. The hard part is memorizing the formula. Alright, so here's a ticket out of the video. You're going to submit your answer in the text box. So the problem is, a spider has taken up residence in a small cardboard box which measures 2 inches by 4 inches by 4 inches. What is the length in inches of a straight spider web that will carry the spider from the lower right-hand corner to the upper left back corner of the box? All that means is find the length of the space diagonal. they use weird words to say, find the length of the space diagonal. So work this problem out and submit it in the submit your answer in the text box when you submit the assignment.